Well, I would love to make this as interactive as possible. So if anybody has any questions, please feel free to raise and we can talk about it. But my name is Chris. I'm one of the co-founders of WhyHow.ai. We're a company that's building knowledge graph infrastructure for a variety of generative AI solutions. Lately, that often means a lot of multi-agentic type solutions powered by knowledge graphs. Before I get into it, though, how many people here are doing RAG of some sort? Or thinking about RAG, maybe? And how many of us are using vector databases? Is anybody using something like Elasticsearch or knowledge graphs? Or like interested in knowledge graphs for RAG? Yeah, there's been a lot of talk recently about using knowledge graphs in the RAG workflow. And I think like a lot of you, we started from a pretty similar place. Maybe like a year ago, when my co-founder Tom here and I and our other co-founder Chio was working on building solutions for a variety of customers in the for example, legal domain or the finance domain, areas in which there are a very high bar for accuracy and repeatability. We were trying to build a lot of AI solutions using existing open source frameworks, vector RAG, naive vector RAG, and we found that it was fast and easy and really powerful, and it got us to roughly about like 80% of the way we needed to get there for accuracy. But for really like, let's say often the traditional domains or domains with a very high bar for accuracy and repeatability, 80% is unacceptable. So we were thinking about ways to really improve, one, the reliability, the repeatability, the visibility, the controllability, the accuracy of our RAG workflows. And that's when I met Tom. That's when Tom started telling us all of these really exciting things with knowledge graphs, about really like having a lot of control of the structured semantic representation of the data, the idea of making very small and modular and granular representations of your data, so that your RAG systems could focus on only just that little bit amount of data that needed to answer a certain question. I'm glad to answer any questions about like our approach, our thoughts in this space, but in the spirit of de-bullshitizing tech and AI, I came prepared with some code and a demo, and I would love to kind of just dive into that and rip in any questions you guys might have. So what I have today is a demo of the platform that our team put together, and it is a graph studio is what we're calling it. It's meant to help users, both technical but also non-technical, come with unstructured data in the form of PDFs or text files, or also structured data in the form of like JSON or CSV, and use either schemas if you want to or not, to go from unstructured data into a structured graph representation of your data that you can then begin to query as part of your RAG pipeline. So if it's cool with you guys, I'm just going to dive right into it, kind of give you a tour, and then would love to kind of address any questions you guys have towards the end. But if you have anything, just please shout out. We can handle it. So this is the doc page. I'll start by giving you guys a quick tour of the UI, and then I can show you the SDK code as well. But everything pretty much starts right here. It's pretty basic, like homepage kind of dashboard for your data. Everything, like most like RAG systems, is based on the concept of chunks. So when you upload data to our platform, everything gets split, chunked, embedded, stored. That way we can use it for graph creation. So chunks can be strings. They can be objects. If I can find something in here that has an object. If you upload, for example, like a PDF, it gets turned to text. We chunk it, we embed it, we attach like metadata that you provide us that we uncover. Or if, for example, if you upload a CSV or a JSON object, one of those objects will be a chunk itself, also gets embedded and then used. So everything here is based on the concept of chunks. So when you upload a document, for example, and since we're in Amazon, we're going to run the example of the Amazon 10K demo that we have. So what I did here was I first uploaded like the 2024 Amazon 10K document, and then that doc was split, chunked, embedded, stored to be reviewed. Next, there's this concept of schemas that we have. So I wanted to emphasize that while a lot of use cases are really conducive to having schema-controlled graphs in the graph creation process, there are also a lot of interesting use cases in which you kind of just want, like an LLM, for example, to just figure out what relationships matter in the data that you have. So for those use cases, there's a lot of really interesting open source tools. I know Neo4j, for example, works a lot with like the folks at LangChain. They have an LLM graph transformer tool, which is really good at pulling out just interesting relationships across all your data, turning it into a triple format, and then storing it in like an Aura database. But in this case, if you want to maybe, for example, tackle a problem with more of a schema-driven approach, we have this concept of schema. So a schema is kind of like our version of like an ontology. An ontology basically tells you like all the different types of relationships you care about, how entities are organized and related to each other in your graph. And in this very simple form, we basically just tried to put together a JSON object. So you have your entities, which represent your nodes in a graph. You have relations, which represent edges, so the connections between the nodes. And then you have patterns. And patterns are maybe another way of kind of saying triples, you may have heard of it, but it consists of a head, a relation, and a tail. Chris works at WhyHow. These are the types of patterns that you want to be able to build into your graph. So we use this schema for two things. One, for extracting data that matters to you from your raw unstructured text. And then we use it to constrain the types of relationships that are built into your graph. And this can be super powerful because sometimes you want to make sure that the semantics of the relationship and of the actual entities that you're querying on are exactly as you expect them to be, so you can have more consistency and predictability in the ways in which your agents or your users or yourself interact with that data. So I can go back and kind of show you how we actually use these schemas. And the graph creation process in the UI is quite simple. So all you have to do is start by selecting the types of data that you want to use to create the graph. So I'll just call this the meetup graph. We're going to select a schema, and I'm just going to pick the one that we talked about before. I'm going to select the chunks I want to use. In this case, all I'm doing is selecting a set of chunks that are labeled with that document title. And what's happening under the hood is we are pulling out all of those chunks that have been embedded. We're then, per chunk, identifying those types of triple patterns, which of them exist in those chunks. And then we're using those to create triples. We combine those triples into a graph. So this graph is being created under the hood right now. I'm going to let this finish up, and while it's creating, I'm going to jump into one I just created a little while ago. This one. Here we go. So I'll jump back to the other one in a little bit, but this is the UI that we've created for exploring and interacting with your graph. So this type of like graph network visualization experience should look pretty familiar. If you've used any sort of network graph, this is pretty basic. But what I think is really important and exciting about the approach that we've taken is we've tried to really bring the information from the raw data itself, the provenance from that data itself, directly to the network graph too. So if we're in here, we look at something like, let's see, AWS. So AWS contributes to revenue, sales, global sales of what is this? Storage, compute, and database. What we try to do here is we try to show you that for any given node or any triple, you can very easily narrow in on the types of relationships that you're highlighting. You can see the individual triples that are being extracted and then shown in the graph. But then what we also try to do is show you exactly where this data came from. So we have the raw chunk text here as well, so that when you find any sort of triple or node that seems relevant or important, you can always trace it back to the source from which it was extracted. And this is important because for people that want to build explainable systems or generate answers that are much more like user-friendly, you have source data that tells you exactly where it came from, so you can have much better kind of generative experiences. Another thing we try to do is maybe the extraction was not perfect. Maybe there's more data you want to add in here, and you want to also attribute it back to the source. So you can do something like, let's just say highlight North America. we can call that a, there's not really an entity here for that. Let's highlight infrastructure. And we're going to call that a revenue stream. Add node. And what you should see up here now is a new node has been created that can then be automatically attributed back to the source from which it was extracted. So we start with our best shot at pulling out all the data that is relevant to you, and then we try to give you all the tools that you need to make sure it narrows back in and is able to map to your understanding of the world. Another couple interesting things. So I saw in here a couple of different nodes called like sales, for example. If I look that up, some of the things that you might notice if you ever try to work with graphs is that entity resolution or entity co-reference is often a challenge. So maybe you'll find the word like sales capitalized, or you'll see like infrastructure sales or like sales organization. And to you, they may mean all the same thing, but to like an LLM or to another model which did the extraction, they could be quite different things. So there are a lot of really awesome companies doing interesting things in the realm of co-reference resolution and entity resolution. But what we try to do is kind of give you a way to be able to create rules and come back in and actually narrow this into your specific understanding of how your data works. So if you look in here, there's like 3 different types of net sales, right? Lowercase net sales, uppercase N, uppercase S, net with lowercase s, like they're all the same node really. So what I want to do is just call this one the winner. I care that net sales is the, say net sales here is the specific entity I want to save and make sure they all are the same like node. All I do is hit merge, hit save as a rule. And now if we go back to the graph, we should only ever see, let's see, one net sales. Let me see if I can find it. There we go. Now we have one net sales node that is basically going to be referenced for across the entire graph. So this is now also, I'm going to come back to here and also highlight this. This is also going to be saved as a rule. So one thing we try to do is make it a bit easier to make sure your graphs are kind of learning, getting smarter over time. So this rule, now that it's saved in the workspace, is able to automatically detect things like net sales that are like of those different syntactical structures, and then always call them net sales. This is just an example of a type of rule. We want to really start to enable these types of graphs to like learn and get better over time.
Did you want to take questions?
Yeah, please.
So wouldn't you just use NLP and lematize it, for instance, to find basically to get all the same stem from things like net sales, so that they all automatically done? Please repeat the question.
Yeah. The question was like, can you use any other NLP processes to be able to automatically detect duplicates, for example? The answer is definitely yes. I think the types of like pipelines and rules and types of customizations we want to be able to add in are inclusive of those things. We want to make sure that data is right the first time. What you're seeing here is basically us kind of taking our first swipe at the problem. We don't want to infer too much upon the user. Maybe they do care about the difference between like capital net sales and lowercase net sales, but ultimately there's a lot of different kind of post-processing or pre-processing workflows that you can implement to be able to do that. So what I just showed here is an example of kind of adding in a rule that does post-processing on the type of data. But I'm going to show you the SDK code shortly that just kind of shows how you can plug that in.
So before chunking, you would do the pre-processing before. Or you chunk it and then pre-process?
Right, so what's happening now is now that this rule is in here, we chunk the code. The question was, are you doing this all before the graph creation during the chunking process? And the answer is we store data as a chunk exactly as it came in, so we can always give back the right data. When we do the triple creation, for example, that's just the language that the graph speaks. So we want to make sure that the graph is following the rules that are in your workspace. So when it's turned into a node or an entity, that's when we apply rules, and that's when we perform post-processing. So in this example here is not RDF. This is just a property graph that we're using, but we've worked with a variety of different like types of solutions. RDF is one of them as well. We love working with like Cypher and like the Neo4j guides too. There's a lot of different types of solutions, but RDF is a great one. It's just not this example. Yes.
Are you going to show us an
I can show you an article I wrote that has that exact type of use case. So I'll flash up the blog afterwards. I'll make sure I give that to you guys afterwards. The question was, can we have some sort of example of a knowledge graph enabled RAG workflow versus a non-graph enabled workflow? So yes, I'll share a blog post afterwards. Okay, so the meetup graph has been created. This looks very similar. It's the same data. One of the things we offer up here as well is exporting to Cypher. So if you want to take this out and then drop it into your like a Neo4j or DB, you can do that. It's just a Cypher command you can run. We offer a public graph endpoint as well. So you can basically take any graph and turn it into publicly accessible data. So if I just open up like a incognito screen, you should be able to see that like you can basically have read-only access to this data. You can't like edit or merge any data. You can just basically poke around and play with it. But like this was really important and relevant to us because even when we were trying to like maybe work with certain customers or ourselves to try to get people to tell us, hey, is this right? Does this look like the right type of like graph you want to see? Can you just double check this real quick? It often came down to just like sharing screenshots or like credentials, and this was just a much easier, more like way for us to be able to do this. So this is one option that we offer, and now we can get into some of the querying as well. So in addition to just doing the graph creation, we offer a query interface. All of this again is API enabled, and I'll show you the example after this, but. You can take pretty much any natural language question or structured question and ask it to this graph. So if we say something like, okay, so if I ask a question in natural language, like what kind of services does Amazon offer, it's going to basically perform like a semantic search over the data that we have stored in this graph, spit back a set of triples that are most relevant, semantically relevant to this data, and then create a natural language answer. So a lot of what you see up in this UI-based demo is like is just that it's a demo. So like asking a question and getting back this data is like really relevant, especially for like a non-technical user. But oftentimes in production or when you're a developer, right, you want to have access to the raw data and then generate the answer yourself, or maybe perform that post-processing on the data to make sure it maps to your understanding of the world. So everything I'm showing you here is API enabled as well. But as you can see, this is the type of data you're going to get back when you run this with an API call. You're going to get back a set of triples, a set of nodes, and then each triple is going to have reference to the data from which it was extracted. So I think you can start to see how this can work into the rest of your RAG pipelines. Instead of maybe doing just a vector search, you can do a vector search and a graph search, or just a graph search. Get back that data, get back that raw chunk data with context as to how it's related to other concepts in your knowledge graph, and then feed that into your LLM to be able to generate an answer. In addition to natural language querying, we offer structured querying, which works much like any other type of like structured query language you might use. So in this case, if I say, for example, business segments and revenue streams, and I want to know which business segments contribute to revenue streams, I'd uncheck this and hit this. This is basically just going to run a filtered query to get back any node that is, or any entity that is a business segment and what contributes to a certain revenue stream. Again, just a regular structured query. Okay, so that's how it works in the UI. I'd love to dive into some code to kind of share a bit more about how this works as like an SDK or API-enabled workflow. Before I do, any questions before jumping into this? Yes? Sure, yeah, the question's about how the schema is constructed. Is the question about how we actually built it, or like what is the format of it? Yeah, good question. So there's a couple different ways that we can build schemas. Right now, I think I'm just so used to working with this. I often just kind of drop something into like in a JSON format and dump it in here. A lot of times when we were getting started with this, we just used like ChatGPT, gave it a format and said, hey, build me a schema that works with the structure and fix it from there. But then we also started working on our own kind of generative approach as well. So I'm glad you brought this up, where we want to be able to use questions from natural language or things that people care about with their data, and then generate for them a schema that we think represents their data. So I'm going to add a couple questions real quick. Okay, so if I can ask some simple questions like this, and this is actually kind of calling back to some of the first use cases that we had in this space. We wanted to take from questions and automatically start to create a graph. And this is exactly how you can do something like this. So if I ask questions like, who does Amazon serve and where do they operate? We find meaningful relationships and entities in this data just inferred. So like I can drag these over and say a company serves a customer, and that's the type of triple relationship I want. If I also want to say a company operates in a country, I can do that as well. And what happens under the hood is this gets constructed into a JSON schema, and then we can just like save it as like a meetup schema, and now we can then use this for creating graphs in the future. Cool. And I'll emphasize as well, like schemas are definitely powerful, but not the only way to create graphs if you're trying to really explore your data a bit too. Yes?
How do you then use that schema in a prompt? Will you just put that schema in a prompt when you're doing all the extraction with an LLM?
So when we do our extraction, we do it we really get pretty granular with like this, like the chunks of data that we're extracting. We also extract mostly the triple level. So the rest of this is very like, it's helpful information. And also if you look at like the types of descriptions here, these often actually act as like prompt injection solutions where this is information we can give to the LLM to say like, hey, like look for information like this is how you recognize this type of entity. But when we look for data we want to pull out, we really care about like relationships between the data and how that relationship ties back to the chunk. So when I'm looking through each piece of data that I've selected for creating a graph, I'm looking for representations of companies, of customers, and then companies serving customers in that example. So there's a lot of tools we use under the hood. Some of them are LLMs, some of them are NLP solutions. But yes, you're using basically individual patterns represented in this schema to extract these entities and those relationships on the like per chunk, per page basis. Cool. All right, so we also have an SDK, and it's quite simple to use. And the use case I have was basically showing how we can create a graph of GitHub commits and GitHub PRs in a certain repo into a graph and asking questions of it. So importing our SDK, and all we have to do, what I'm using for this example is I'm basically using like the Boto3 repo. So everybody should be pretty familiar with that. So I added an element in here as well. I can come back to this as well, but this is basically just a quick prompt to summarize some data to make it a little bit more semantically meaningful on the graph. Okay, so all I'm doing is I'm going through the GitHub API, and I'm pulling in PRs. I'm pulling in user data from each of those PRs, and then I'm also pulling in commit data and user data from those commits for each of the PRs. So if you think about the type of like graph structure we're building, we're thinking about like a repo. A repo has has PRs have commits, and users are committing or submitting PRs, or they're contributing commits. Those are the types of relationships, and you'll see the kind of triples that we're constructing at the bottom. But all we're doing is doing some simple parsing. We're pulling out the data, we're pulling out commit data, and then PR data. And then what we're doing is we're using this information to then construct the elements of a triple. So a triple, as you can see up here, what we're pulling out is like a triple model, relation model, and then a node model. So like we said before, triples consist of nodes of relations. So with every triple, we need to basically define a head node, a tail node in their relation. So in this example, I'm creating a node here for the repo. So I'm basically just saying this is the Boto3 repo. For this, I'm basically creating a node or a PR node. So I care really about the title of the PR in this case. I'm gonna start running this too while we're at it, so we can prove this works. And then, in addition, I'm pulling out the commit data as well. So I have a commit node down. Where is it? I have a commit node down here, and you can see what I'm doing with these triples is I'm basically defining the structure by saying a head is the PR node, a relation is submitted to, and the tail is the repo node. Actually, this should say like is part of. This one, a PR was submitted by a submitter. A commit was committed by a committer. So these are the types of triples that I expect to then see in the graph. Now, this is the difference between doing this by the schema constrained approach versus kind of just using the API to do it ourselves. I maybe don't necessarily know exactly the types of relationships I want or the types of entities I want when I'm kind of building this thing. Or maybe I want more flexibility to be able to create this graph the way I want to. In this approach, you don't have to conform to a schema. We can just infer the schema for you as you continue to add and update data. Okay, so this ran already. One cool thing I'm doing here that I wanted to call back to, if you ever look at some of the commit body or the commit text, you guys should know it's a little bit messy, a little like hacky sometimes. So instead of like trying to show like literally some code like in the name of the node, I basically just asked like the LLM to generate me a summary of like the commit note and then just called that like the title of the node. So you'll see that in the graph as well. Okay, so the triples have been generated. They're basically sitting in an array now, and I can print this out for you too. So what you'll see here is the triple object, which is a head, which has like a PR, has the name of the PR. It has chunks that you can link in here, which I haven't done, but you can definitely just like upload the data and make sure it's mapped to that node. Some property data, which basically just gives metadata about that node, and then the body of it, and then there's the tail node right here. So it should map pretty much to the structure that you've seen in the UI. And what we're going to do is we're just going to create a graph just by running our create graph command. So I'll just call this the meetup GitHub demo. And that's it. So if we go back to the console, we'll look for our meetup graph, the one we just created. This is what we've created. So this should actually just be pulling in like the top, I think limit is like, I don't know, it's like 20 or mid. This might actually just pulling in the open PRs right now. But what you can see on the side here is the exact type of entities and relations we defined, right? Commits, PRs, repos, and users. Boto 3 has all these PRs. A given PR has a commit, and then the commit has a user. And those are the types of relations that exist across the entire map. So now that we have that data in there, we can actually start to query this a bit as well. So what I can now do is ask questions in a variety of different ways. Like you saw before, you can run an unstructured query, which basically allows you to ask a question in natural language. So this is something I was running earlier. Let me show you the other graph I was running this again. So, all right, this one's a little bit different. This is a bit of a bigger graph. I'm not sure if this guy, Tim Finnegan, or Finnegan is here, or if he like works here at all, but I was using his name and his data a lot for this demo. So I really want to know maybe if I'm working at like, if I'm working at GitHub, working at Amazon, or if I'm like part of the open source team, I really want to know maybe what a certain employee is doing, or like I want to know a bit more about who worked on a specific PR I just can't remember the name of. I can then use like this type of query approach to be able to learn a little bit more about this data, not just in a structured way, but also using unstructured data as well. So if I ask a question like this, just like which PRs did Tim Finnegan submit? What this can then do is basically run the unstructured query, go in, find the related triples, spit back an answer, much the same like we just demonstrated. The structured query works quite the same, but it's quite a bit faster. It's fully deterministic and it's very reliable. So now we get back just all the same data, but I had to know going into this that I care about Tim Finnegan, I care about the submitted by, and then PR and user entities. But what happens if I don't know that information? What happens if I'm trying to build a system by which somebody can just ask a natural language question? I have to kind of figure out maybe which entities to call upon, or I want to ask, or maybe know like which kind of graph to be able to talk to. There's a couple different examples I wanted to show you here. So in this one here, these are kind of a couple different hybrid type approaches. So in this example, what I'm able to do is basically infer the types of entities and relations based on the schema. So what I'm doing is I'm basically saying, hey, go get me the schema ID for this graph. And the schema ID should contain the PRs, the users, the repos, the commits. For that schema ID, I want to then detect which entities and relations actually matter for the type of question I'm asking. So I just wrote a quick prompt here, and I said, go through these schemas, go figure out, based on this question I'm asking, which entities and which relations from the schema matter. give them back to me, and then I'm going to use those to run a structured query. So what I did is I basically took the output. I can print, I'll run this so you guys can see how it works, but it basically gets the schema. It finds the relevant entity types and relations and values. And then what it's going to do is then use that data. It plugs it into a structured query here. This is very much the same as we ran before, and it runs that query, and it gets back the same data. But this time, instead of just printing out the raw output from the system, we're feeding it into an LLM and asking it to summarize the information. So what we actually get is a bit more of a structure, kind of well-structured, more detailed answer with information about like that's contained within all the properties. So when it was updated, what the body of it actually is. So this is one type of like hybrid approach, but another one that is like interesting and I think like particularly like exciting about doing this type of work with graphs is this concept of completeness. So I have a blog post I'd love to kind of share with you guys as well at the end. I'll just flash it on the screen, but one of the cool, exciting things about doing this type of work with graphs is that you're not necessarily limited by like having a top K like relevance. You can retrieve as much data as you need. As long as you know the structure of your graph, you can go in and retrieve as much data as you need, pass it in your LM, and know for sure that you've retrieved the data that you need to be able to answer a question completely. So doing this, though, from a natural language question into a structured query to get this data out is a little bit tricky, but this is the pattern we started working on to kind of like be able to solve for that. So let's say like we go back to this graph, and where's our guy Nate? There's a guy in here named Nate I've also been working with quite a bit. All right, so Nate here has been pretty busy, right? He's been working with, let's see, he's been working on a lot of different types of PRs, several different types of commits. And let's say, for example, like, you know, your VP of engineering or you're like working on an open source project, you want to just know like who's been working on a specific commit or I don't know what one of your teammates has been doing. So if I run this type of query for the unstructured, this is essentially a probabilistic query. It's running that top K type response, getting back the triples and trying to summarize an answer. And what you can see here is that we're only getting back 9. Which is actually incorrect. It kind of is up earlier. There's 13. There's 13 PRs here that Nate is related to. One other thing I wanted to point out is that we are just using like the word Nate. We're not using the actual like node name here. We're trying to actually infer who this person is based on the similarity of that name. So 2 challenges here, right? Is finding the right Nate and then making sure we can get back all the data. So one type of approach that we have here, in addition to the inferring the schema before, is what we do is we get back all this data here from the unstructured response. If I print this out instead of just the answer, you'll see all of the raw data that we were showing in that query interface earlier. So answer is just one component, but you'll also see the graph, the raw data that makes this up. So these are all the different triples. If I scroll over here. These are all the different triples that make this up. And then within your triple, you get an ID, you get a node, you get an entity type, all the data that we needed to then actually create that structured query. So what I'm going to do is I'm going to go through that answer. I'm going to pull out the labels for the heads and the tails, the values and the relations. And I'm basically going to say, this is all the information that appears relevant according to my natural language query. I then want to use that data, both the labels and the commits and the users, the values. And I just want you to go get everything for me. Go find it all. Just tell me like what this person's been doing. And then I want you to use this information to then generate a summary. So what I got back here, if I just print out all the triples that have been created, this is basically what came out from the initial part. But this is all of the like data that seems relevant to that type of question, but brought back in a fully complete and structured way. So now what I'm going to do is I'm going to feed that answer into a prompt that just says, here's the question, here's the response that we got in the form of the triples, and I want you to then answer the question based on this context. And what we should get now is all 13. So now we see that we have a way to be able to kind of like start from unstructured, find out which types of entities or relations are relevant and important, use that to get a more complete answer, and then work that into the rest of our RAG pipeline to be able to do some post-processing and generate our answers. So from this, you can also just pull out other chunks of data. You can do your own post-processing on this information, do lookups to databases, to other like vector data stores. This is meant to integrate directly into your existing RAG pipelines, but give you a lot of confidence that you're querying data in the querying semantically rich and structured data, but also able to kind of unlock that completeness factor as well. So we've been doing some interesting benchmarks in this stuff. I'll jump over to our blog so you can see that as well. It's just enterprise RAG on Medium, and you can see some of the types of research we've been doing here. There's an article a bit on the completeness type argument. There's a lot of interesting things we're talking about here when it comes to like multi-agent to multi-graph type questions. A lot of the exciting patterns we've been thinking about lately is like, what does it look like to have like a graph per agent to ground each agent's like worldview in the context of a semantically rich knowledge graph. That's a really interesting approach. A lot of kind of multi-hop, multi-section type workflows as well. Definitely some interesting things in here. And then that article on graph versus vector versus a lot of other type of like use cases in here as well. So if you have any questions, please definitely check out the blog post. But before that, I'm glad to take any other questions if you guys have them. Yeah.
I mean, I agree that the structure of GitHub repos are going to be easy to transfer into a graph. Can you get an example like this running on just text?
Yeah, sure. I mean, I would love to kind of, is there a specific type of question or use case that you have that can maybe try to run another query that kind of shows you what this looks like as well? Yeah, sure. Let me show you this real quick. So I think your question is kind of hitting on, yeah, great, it's structured data, but it's pretty predictable what type of like maybe text or entities exist in there. But what if I like don't really know what type of like data I'm looking for? I can ask a question like this, like who worked on S3 stuff? Let's see what this comes back with. So the value of this, and I think the power of doing both like structured and semi-structured data or structured and unstructured data in a graph is you can search on that unstructured text. So if I look at this right here, right, you can see like the data that came back. So the answer is Tim Finnegan and this person. So what we did was when we asked this question, like who worked in S3 stuff, we basically performed a semantic similarity search to discover like which entities or which PRs are related to that term S3, right? So we came back with this node. From there, we were able to then like understand that ticket was submitted by, or maybe this one commit was worked on by this other person. And we were able to pull together this answer. So I can share with you some other notebooks as well. If you actually go to our documentation and then check out the example section in our docs, there's other ways that kind of show you how we're doing like this type of search over all unstructured data versus like semi-structured. But what I just demonstrated is that we can start with something that is unstructured, start with something we don't know about, and then use the structure of the graph to kind of get other more relevant tech context that's been defined by us in our schemas.
Well, if you have a question, raise your hand and I'll bring the mic to you so we record it. It's a very long room, so I'll get a lot of exercise. Bear with me.
Thank you. Yeah, so for that example, so I interpreted the question that just happened. I didn't understand if your answer was different than how I interpreted it, but it sounded like the question was, what if the data that you have is not structured in any way, like just it's an essay or something, it's just one big blob of text, then can you infer do we have ways to build the graph not from a structured format? And I didn't understand if the thing you just said in response was an answer to that, or if it was like how you do a unstructured, you can take an unstructured query and turn it into a query against a structured graph.
Yeah, you're right. That's exactly the question I answered. So to answer your question though, so yes,
that was the original question. If that was the,
yeah,
I didn't know, was that the original question? Okay. Okay.
Yeah, you nailed it. Yeah, you caught me. Yeah, so that what it just demonstrates how to start from unstructured querying and then work your way into more structured data. But I don't have the code. I don't have the notebook up right now, but I can pull in. This is actually an example I worked on not too long ago. So this is basically to demonstrate how like completeness works. There's a lot of different ways to pull out this type of triple data. from unstructured text. The first way I showed you is like our engine up here. So if you basically run that create graph and you specify a schema, you're relying on us to use that schema to then like use these triples, go through each individual chunk, pull out text from those chunks and say, hey, great, this is a triple that matches the schema. There's other tools like I mentioned that are pretty powerful, like LLM graph transformer, right? That we talked about before. That if you haven't used like that LangChain tool, like take a look at this. LLM graph transformer just lets you pass in like PDFs, for example. You can specify the different types of relationships you want to see, and it'll rip out triples for you that you can then import directly into Neo4j. But the other example I want to show you is kind of just a bit more rudimentary. So here's a really simple prompt I wrote that kind of just shows you like how you can use an LLM, for example, to pull this text out. So in this example, this is actually another Amazon 10K example. I use like LLM Sherpa to basically, if you guys haven't heard of LLM Sherpa, it's like, it helps you extract like text, but also structure from PDFs. But I basically use LLM Sherpa to then find me sections that are like financial proceedings, or I'm sorry, like legal proceedings, or like the legal aspects of a 10K document, because I wanted to build a graph of the like legal things Amazon had to deal with over the course of like 2024 or several years. So this is all the data, right? I have like 10K documents from Walmart and from Amazon in here. We kind of show here about how you can use, how it compares to doing vector RAG with Pinecone. So definitely check that out. And then if you actually want to do the triple extraction, what I'm basically doing here is I'm taking that PDF and turning it into text and chunking each one. And then I'm going through each chunk, or I'm going through top K chunks to retrieve from a vector database. And then I'm saying, using this context, right, like build me a triple that looks like this. And I want it to come back in the form of like a head, a relation, and a tail. So you can trust this to an LLM. You can trust it to your own models under the hood. You can trust it to us. You can trust the LLM graph transformers. A lot of different ways to do this. But what pops out from here is a list of triples that we can then put into that same format. I then serialize them and then put them into make sure they map to the model that WhyHow uses, and then use those to create the graph. Structured data, also very easy to work with because of that, but unstructured data is just a matter of deciding which relationship exists in there. You can use a lot of different tools to do that.
Other questions? You guys are on the far end. You've been quiet. If you have a question, I can run to you. Any more questions? Sure. Let me bring it.
You mentioned 80% on accuracy on legal before you started using these techniques. So what's the accuracy that you reached? What's the highest accuracy you reached in legal documents?
In legal documents?
Yeah.
Actually, Tom, you might be able to answer this question if you want. We actually just started running some tests on this stuff just this past week to kind of compare both doing like RAG against like GRASS versus vector databases versus a variety of other things. Also, if you guys have used RAGAS before, it's also a really great tool you can use to kind of answer this question. Sorry, I'm putting my co-founder on the spot, but the question is like, how does accuracy compare with doing these types of like use cases with graph RAG? We were asking specifically about legal documents, but the higher level research we've done is more about like kind of graph RAG versus other RAG solutions as well.
Yeah, nice accent, by the way. Yeah, so it's not really a fair comparison because I can get 100% on a document if I spend enough time on it, right? There isn't really like a benchmark data set that we can compare against. We were using RAGAS for like a larger academic set, and RAGAS has things like faithfulness, similarity, complexity. You can use recall and precision, however you want to manage that. As a general set across like 100 academic documents for about 1,000 questions that have a golden data set, we're probably looking at a lift in faithfulness of about like 45 to 55%. And then accuracy, you're probably looking close to 30 to 35. But again, that's like a generalized benchmark that I wouldn't really use. Like we can put those numbers up if you want. You can potentially get published with them, and we will and we have. But when it comes down to your specific problem, it's like it just depends how long you want to spend on it. And I think the important thing about the structure of graphs and how you retrieve them is if you spend enough time and you iterate, you have explainability, and you can iterate and change and update and stream in. Like we spend a lot of time on streaming. So the answer is 100, but it's not really a fair comparison.
And this is not necessarily about the legal use case. There's another article we released that talks about doing like multi-agent, multi-graph, multi-section of multi-documents type retrieval workflows, which is definitely pretty interesting. But this type of benchmark we ran was actually just using that 10K example to then figure out like how many correct answers can we get of all the legal proceedings that occurred, and do we do it with varying numbers of documents mentioned in a single graph? How does it compare to doing it with vector RAG as well? And some of our findings are in here.
Thank you, Chris. I think that's all the time we have for the first talk because we need still to get to the second talk by Mihai. So let's thank Chris again and Tom.
Thank you. Thank you, guys. Thank you.